This is a system which collects disoriented containers as they are fed from an in-press conveyor at a rate of up to 250 per minute in this vibratory tray. The system is designed to handle containers whose length is equal to or greater than their diameter. Where the L/D ratio is less than 1, we should consult carefully before selecting this approach. The tray is designed to feed the parts to an elevating conveyor after having pre-oriented them so that they enter the conveyor properly. Any incorrectly oriented parts will be automatically recirculated through this conveyor and re-enter the system to be oriented correctly. The elevating conveyor lifts and conveys the parts to the transition area, where we begin the process of changing their orientation from open end up to open end forward so that they will stack together effectively. Next, the parts are transferred onto these rotating bars, where the rotary motion ensures smooth and effective nesting of the parts so that the stack count can be mechanically controlled. Once a given adjustable stack height has been exceeded, a mechanical separator separates the stack into a pre-measured length, and the stack is transferred to the storage table, ready for inspection and packing. The unit is very flexible and is also portable, easily moved and reset from one molding machine to another. Here's the machine designed to collect, stack, and fully automatically package molded containers as they flow from a molding machine. The containers could be discharged from the molding system either by a robot or by mold-mounted swing chutes. But the primary requirement of this system is that the containers arrive at the stacking machinery in oriented condition, open end down. As can be seen from this overview, the system first guides the containers into lanes and then a pattern of stacks. For the objective of this system, which is to feed the stacks into their storage carton in horizontal orientation, the pattern of stacks is not important and can be designed to optimize the frequency of the stacking motion. If, as is sometimes the case, the stacker feeds a semi-automatic carton filling station where the carton is lowered manually over the completed pattern, then the pattern would be designed to correspond with the carton size. As each pattern is completed, the conveyor is indexed and the servo drive system of the stacker begins the stacking sequence again. At the same time, completed stacks of containers are now fed into a hopper where they are allowed to reorient horizontally. The cleated conveyor running through the hopper lifts each stack individually and feeds it to a collapsible chute or snorkel, which accurately places it within the storage carton with polyliner. The polyliner is the reason for the collapsible snorkel. As you can see here, the indexing table of the box filling system positions the carton with polyliner centrally before the carton is lifted to encompass the collapsed snorkel. The mechanical action of expanding the snorkel only occurs when the carton has been accurately positioned to accept the stack release. In this way, it is not critical to organize the polyliner smoothly within the carton, and the stacks flow into position without impediment. When the carton has been filled, the indexing table is lowered and a pneumatic push plate deposits it on an exit conveyor, while a new empty carton is placed in position for the next filling sequence. This system can handle a wide variety of container sizes and is capable of speeds of up to 18 stacks per minute through the carton filling section. Let's look a little more closely at some of the design details of the machine. In this particular case, the containers are being fed from mold-mounted swing chutes onto this conveyor, which guides the parts into the stacking machine. Notice that the conveyor is designed to reverse slightly at each stacking cycle. This is to prevent any interference of following containers with those being stacked. The system measures by photosensors that a complete matrix of parts has arrived on the stacking table before the stacking motion is signaled to begin and the conveyor reversal takes place. The stacking action is provided by a pick-and-place mechanism driven on two axes by electrical servo motors which are programmed to adjust to the stack height difference of each layer of parts. The pickup arm is built from rectangular, hollow-section carbon fiber tubing, this material having been selected both to minimize the mass of the pickup arm and so that the arm can also act as an air conduit for the high-volume, low-pressure air, which is used to capture the parts in receivers, which locates them accurately for stacking. The system is easily programmable to run a series of different containers with minimal changeover time. The change from one container and stacking pattern to another can be achieved in approximately 30 minutes or less. The carton filling system is designed with servo drivers for both axes of the indexing table, so as to improve the speed and accuracy with which the cartons can be positioned for stack loading. As always, CBW sells this innovative automation equipment with an installation visit by a qualified technician included, so that you can get the benefit of this cost-reducing technology quickly after receiving